Hello everyone and welcome to this video. This is the first video for the series of videos for organic chemistry. We shall discuss some important aspects of organic chemistry in this video series. So what is organic chemistry? It is basically a branch of chemistry which deals with the study of carbon based compounds. It is so versatile field that it's been given a separate branch in chemistry. Now let's see some important properties of carbon. First, the structure. Carbon has 4 valence electrons. It means valence electrons are the electrons which are present in the last shell. Apart from that, carbon believes in sharing of electron. It believes in covalent bond. Carbon shares electron to become stable. Carbon has the ability that it can make single bond, it can also make double bond, and it can also make triple bonds. Another important property, very important property of carbon is the property of catenation. What is this property? Making long chains of carbon. Long chains. Like carbon bonding with one carbon, making a bond with another carbon, making a bond with another carbon. This property, unique property of carbon is called the property of catenation. Apart from that, carbon has straight chain compounds, branch chain compounds, rings, aliphatic compounds like ring structures. Then we have aromatic ones which are like alternating single and double bond. That these all properties make carbon so versatile and special that there is a separate branch of chemistry for this, which is known as organic chemistry. Now when there is broadness, when there is versatility, there need to be proper element of classification. If we can classify things, life can become easy. So classification is very important in chemistry. So in organic chemistry, you will find something which is known as homologous series. What is homologous series? It's basically grouping of compounds. And how do you group them? When you make groups, there must be some similarities when you are making a group. Consider, like for example, you are making a WhatsApp group for immediate family members. And that particular group, you will only add family members. You will not add me or your friends in that group because the rule says it's for family only. For example, you are making a WhatsApp group for chemistry students only. Now in that group, you will only add the students of chemistry with you. You will not add your family in that. Similarly, when you are designing a series, a homologous series, what is the rule? The rule is that you can group compounds together based on some similarities. Similarities in what? Either in their structure or in their reactions. So they must have some similarity. One of the most important homologous series is a big broader version. We call them hydrocarbons. Hydrocarbons do come under the section of homologous series. What are hydrocarbons? If you want to classify a compound as hydrocarbon, it must only be based on two elements, which are carbon and hydrogen. If you have a compound in which only these two elements are present, we will call it a hydrocarbon. Let's go through some important hydrocarbon series, but before going to the series, I will give you some information that you should memorize. You should keep it with you, like if it is based on the number of carbons. For example, if you have one carbon, we say this is meth. If it is two carbon, we say it is eth. 3, we call it prop. When you have 4, we call it but. When it is 5, we call it pent. When it is 6, it is called hex. When it is 7, it is called hept. When it is 8, it's called oct. When it is 9, it's called non. And when it is 10, it is called dec. At least we should know first 10, like 1 carbon is meth, 6 is hex, 9 is non. When you know this, then naming them or identifying the compounds become very easy. It becomes easy to understand. Okay, now moving forward, let us discuss some important hydrocarbons. The first one, the very famous one, we call them alkanes. Alkanes are hydrocarbons, but they are also a homologous series. So this is basically a name of the family. You can call it like a name of a WhatsApp group. Now, what are the rules? What are the rules that if some compound you want to classify as an alkane, first thing, it is only based on carbon and hydrogen, because this is a hydrocarbon. It is a hydrocarbon, so it must only be based on carbon and hydrogen. Apart from that, if a compound has to be alkane, it must have carbon-carbon single bond in it only. It can only have carbon-carbon single bond. For example, a compound has carbon-carbon double bond. It can be something else, but it cannot be alkane, because the rule says if you want to come in alkane family, you must have carbon-carbon single bond, and the others only can be hydrogen. The other can only be hydrogen. These homologous series do have a general formula. The general formula of alkane is CnH2n plus 2, where n can be like 1, 2, 3, so on, up to how long you want the series. Okay, the smallest one, if you put n1, you get the series, which is CH, 2 ones are 2 plus 2 4, so CH4. This is the smallest one. There is a suffix. Suffix means to identify. In the last of alkane, any alkane, you will always find ane in it. You will always find ane in it. Now, if you remember this naming, this number of carbon naming, you can name alkanes very easily. For example, if you look at this one, this is 1 carbon. Meth. So meth in the N should be ane, so it can be called methane. This is classified as methane. Similarly, if you have 2 carbons, there should be carbon-carbon single bond only, and one remaining all should be hydrogens. So this is 2 carbon. 2 carbon is called eth. So at the last of alkane is always ane, so we can call it ethane. Similarly, if it is 3 carbon, you call it propane. When it is 4 carbon, you call it butane, like this. So if you know this number of carbons, you can easily name them just by counting the number of carbons. So these are the simplest hydrocarbons. We call them alkanes. Moving forward, the second series, which is very famous, this is also a homologous series specially characterized with hydrocarbon only. We call it alkene. Consider it like a WhatsApp group. Which members can be added in this family? Only those members which are first based on carbon hydrogen, because we mentioned it's a hydrocarbon series we are discussing, and the rule says, what's the rule? Rule is that only those compounds can come which have a carbon-carbon double bond in them. If a compound has carbon-carbon single bond or some other bonds, it cannot be alkene. For an alkene, it should only be carbon-carbon double bond, and remaining should be hydrogens. The suffix, it will end, alkanes end with ane, this ends with ene. This ends with ene. Apart from that, when we talk about the general formula is CnH2n. Okay. Now some important discussion when you want to complete the structure. For example, you want to draw an alkene with 3 carbons, like you want to draw for example propene. For now we don't want to bother with the position of ene, but for now just consider it like this. Prop means 3. It has 3 carbons, so we draw 3 carbons, 1, 2 and 3. Because it's a ene. Ene means it's belonging from alkene family, so it must have 1 carbon-carbon double bond. Let's make this carbon-carbon double bond. Now we want to fill it with hydrogens. You can count it like this. For example, carbon has 4 valence electrons. Carbon needs how much more? Carbon needs 4 more to get stable, because we know that the condition of stability is that an element must have 8 electrons in the last shell, other than the 2 ones which are the smaller ones only. So it needs 4 more. So you can count it like this. 4 it already has, 5 shared with this. So 4, don't count is 2 electrons. Consider like 4. If you count 4, this becomes 1. So 4, 5, 6, 7, 8. Here you can also count 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. When you take 4, you don't want to count these two, so it will not create mistake. You have 4, how much here? 5, 6, 7, 8. So if you count how many hydrogens are there, 1, 2, 3, 4, 5, 6. So it's like C3H6, and these are all hydrogens. These are all hydrogens. Similarly, you can draw propene, you have butene, you can have ethene. You cannot have methane. You cannot have methane. Methane does not exist. Why? Because the condition is that you must have a carbon-carbon double bond, and in methane it's not possible because meth is just one carbon. So you cannot make double bond in that. So this is the second hydrocarbon series, which is alkenes. The third one is the very famous, we call it alkynes. Alkynes are those homologous series which have carbon-carbon triple bond in them. They must have a carbon-carbon triple bond in them. This is their, you can say, like, to organize what's the rule, that should have carbon-carbon triple bond in it. Then this suffix, it will end with "-ine". The compound name in this series will end with "-ine". The general formula is also called CnH2n minus 2. This is the general formula. You can start and end with 2, 3, 4 again. Let's try draw one more structure. Let's take the same example. We take propene. Let's do one more. We have carbon bond with carbon, bond with carbon. To make it an alkyne, you must have one triple bond. So let's make this a triple bond. Now again, we want to put hydrogen to make everyone stable. So we have carbon 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. It's already stable. So 4, 5, 6, 7, and this one is 8. So if you count here, you have hydrogen, you have hydrogen, you have hydrogen, and you have hydrogen here. So you see, if you count, it's how much? C3H4. You can count it. It's carbon C3. If you double it, 6 minus 2, 4. It follows the general formula.